Welcome to the Walton Pi. Today we're going to be talking about how we can use what's referred to as the tabular method for doing integration by parts. Okay, so the tabular method is when we are trying to do integration by parts and we have something like, let's suppose we are trying to integrate 3x to the fourth e to the 2x dx. If we're trying to do this by integration by parts, well, the way we would pick this is we would say this is u, and then this is your dv. So u is 3x to the fourth, so then du is 12x cubed. If we have dv is e to the 2x dx, then v is going to be e to the 2x over 2. And we're going to just continue this process, so this would turn into, let's see, we get this is equal to 3x to the fourth e to the 2x all over 2 minus the integral of, let's see, we got a 12x cubed times 12x cubed times e to the 2x over 2 dx. And then this integral we're going to have to do by integration by parts. And so this is just going to have term after term after term, and it's just going to take a really long time to go about figuring this out. And so the tabular method is a way of being able to figure out what this is going to go to very quickly without having to go through all of these individual steps in between. It's basically just doing a shortcut to all of these steps all at the same time. So the way that we are going to do this is we are going to start by making a table, and one column is u and the other column is going to be our v. And so what we put in our first, or I guess v, or sometimes I see people do it as dv. So what we are going to do is we are going to put what our choice for u was in our first column. So that was a 3x to the fourth, and our choice for dv was e to the 2x dx. And what we are going to do is we are going to go down this direction, and these are going to be successive derivatives, and then going down the other direction on this side, these are going to be successive integrations. So if we were to go down the derivative side, 3x to the fourth, the derivative of that is 12x cubed. Then the derivative of that is going to be 36x squared. Then we have 72x, 72, and then we would have 0 after that. What we are then going to do is we are going to do successive integrations on the other side. So we have e to the 2x, then we have e to the 2x divided by 2, e to the 2x divided by 4, e to the 2x divided by 8, e to the 2x divided by 16, and e to the 2x divided by 32. And as soon as you're at the row that has 0, that's when we're going to be done. The way we are then going to clump these together is we are going to combine going on these diagonals, just the u with the entry in the v column that was right below. Because if you remember this first thing, this was dv, and then this is going to be v. And our form is uv minus the integral of v du. And so if we just keep taking derivatives, it's going to just have these sorts of things just pop out. The only other thing we have to remember is because of this negative sign that's showing up here, we are going to be alternating signs on these diagonals. So this first one is a plus, then this one's minus, plus, minus, plus. And these are not saying we add or subtract u, like v from u. It's saying that we have a positive product of those, and then the negative sign says it's a negative product of those. So if we were to just chain all of those together, what we would then get is we would get the integral of 3x to the fourth e to the 2x dx is equal to, we have uv, so our first term, 3x to the fourth times e to the 2x all over 2, because that's a plus. Then we have a minus, because the next term is negative, and the next term is 12x cubed times e to the 2x all over 4. And then the next term is plus, so plus 36x squared times e to the 2x over 8. And that is just this going down the diagonal with this term. And so that's how we're able to be figuring out these different terms. So the next one is going to be this 72x down the diagonal, e to the 2x over 16. So that's what this one is. We have minus 72x, e to the 2x all over 16, and then we finish with a plus 72 e to the 2x all over 32. And this, maybe with a little bit of simplification, is the answer to that. Oh, plus c at the end. And that's going to be what this integral is. And so this is the tabular method. It's often taught as the shortcut, but in some situations, for example, the integral of e to the x sine x, if you do only using the tabular method, you don't necessarily see that this cycles back to itself. And so that's why with these sorts of things, only knowing the tabular method is not going to be super helpful. It takes a lot of practice to be able to recognize this integral showing up again inside the tabular method. And so this is a method that you can use, but I would recommend still practicing and remembering the other method, or the standard way of doing integration by parts, just so that when you come across things like this, you are not going to be left stranded and very confused as to what to do. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already, so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.